Here is the next example. In this example, he clearly mentioned it's a RLC series circuit, and the voltage across this circuit is given in the waveform format, and the current is also given in the waveform format. Those are the that's the given data. Now, when you're looking at the waveform here, see it reaches to the maximum value at 0 degrees. So can I write this waveform as E equal to E naught cos omega t? Since it is starting at 0, that value is going to be 0, plus 0. Okay, so here E is the instantaneous value, E naught is the maximum value. Okay, so this is going to be 10 cos omega. Omega is nothing but 2 pi f. So omega is nothing but 2 pi f, and f is nothing but 1 over t. We know the time period is 100 microseconds, so frequency is nothing but 10 to the power of 4 hertz, which is 10 kilohertz. Okay, so 10 cos omega t plus 0, that's E. Now if you look at I equal to 2, the magnitude is also same 2. For this the magnitude is reaching to 2, so 2 cos omega t 2 pi ft. Here we will end up with plus or minus theta. I don't know what is theta, we'll find that theta in a second. Now if you look at here, the instantaneous value at this point is 1. Okay, so if I substitute this 1 here in the instantaneous value right there, 1 equal to 2 cos 2 pi f and t, they both cancel out because t is 100 microseconds there, and f is 10 kilo. So 2 pi plus theta, 2 pi is nothing but 360 degrees, so I can eliminate that. So cos theta equal to half, theta equal to 60 degrees. Now am I going to use the positive or negative there based on which one is reaching their maximum value first? Is it voltage reaching the maximum value first or current reaching the maximum value first? So if voltage is reaching the maximum value, then that is coming first and current is coming next. So in this case, I can clearly see voltage is coming first and current is coming next. So current is basically lagging. So I have to take that as a minus 60 degrees. Now what I'm going to do, I'm going to convert that into RMS values. So this is instantaneous value. I converted that into RMS. I'm using, instead of E, I'm using V. Okay, so if I draw a vector diagram for this, so V is going to be right there, I is going to be somewhere here. So this is vector diagram, and that's 60 degree angle. Okay, V and I. So Z equal to V over I. So 10 over square root 2 over 2 over square root 2 at an angle of minus 60. We will end up with 5 at an angle of 60. That's our Z. Okay, so this Z is in polar format. Convert that into rectangular format. So when I convert that into rectangular format, I end up with 2.5 plus J, 4.33 ohm. Now, so that Z is nothing but R plus J. Since I have plus, so it must be plus JXL. But in the circuit, in the given circuit, he clearly mentioned that value is, it's RLC series circuit. So basically, XL is bigger than XC. So that's the reason I'm writing this as XL minus XC. So he was asking for R, we already found R value there. And XL minus XC must be equal to 4.33 ohm. So 2 pi FL minus XC, XC is nothing but 1 over 2 pi FC equal to 4.33. So if we substitute everything, and final value C equal to 1.26 microfarad. Here is the next example. In this example, it's a RLC series circuit. Values are given: 46 ohms, 2.5 millihenry, and 530 nanofarad. Okay, it's a RLC series circuit. He also gave you the maximum value, E naught 5.5 volts, and frequency 3 kilohertz. So first thing I'm going to do, I'm going to convert XL, inductance into inductive reactance and capacitance into capacitive reactance. So I have JXL equal to J omega L, so I end up with J 47.12 and minus JXC. So remember, inductive reactance is always positive, capacitive reactance is always negative. So minus jx equal to minus j 100.1. So from here it's RLC series circuit, so the total impedance Z equal to R plus jXL minus jXZ, 46 plus j 47.12 minus j 100.1, approximately it is 46 minus j 53.1 or 53 ohm. Okay, so it's a RLC series circuit, but at the end the circuit is behaving like a RC circuit, resistance and capacitive reactance. Now since I know E0 value or V0 value, I can find I0. I0 equal to V0 over Z, which is 5.5 over 46 minus j 53. So 5.5 over 70.178 at an angle of minus 49. So converting this Z rectangular format into polar format. So I end up with this current. Now if I take E0, or if I take E equal to E0 sine omega t, then my I will be I0 sine omega t plus 49 degrees. The 49 degrees came from here. Okay. So if I draw a waveform, the waveform is going to be look like this. Or if I draw a vector diagram, here is my E and here is my I. The angle between these two is 49 degrees. This is a vector diagram. Now the question he's asking about, find E when I equal to I maximum. Okay, so basically if I draw the waveform, so this is 0 degrees and here it is starting at plus 49 degrees. So the I maximum is going to be somewhere here. At that point, what is I? That's the question. Okay, so if I substitute I equal to I maximum 0.078 equal to 0.078 sine omega t plus 49 degrees. So I'll end up with sine 1 equal to sine of blah blah blah, sine inverse of 1 is 90 degrees. So omega t equal to 49 degrees. So 90 equal to omega t plus 49, omega t equal to 90 minus 49, end up with 41 degrees. Now if I substitute that 41 in E to find that instantaneous value, end up with that value is 3.608 volt. In third case, he's saying that I equal to minus I0. So here minus I0 is going to be somewhere here, 180 degree difference, right? So basically whatever the voltage here, same voltage is going to be here, it's going to be negative. So third case, it is going to be minus 3.608 volt. Okay. The next question he's asking about, when I equal to 0, find E. Okay, when I equal to 0, find E. So if I substitute I equal to 0, omega t E, I end up with minus 49 degrees. If I substitute minus 49 in the given equation, sinusoidal equation, I end up with E equal to minus 4.15 volt. A third case, as I mentioned previously, I equal to minus I, then omega t must be 41 plus 180 degrees. So if you substitute that value, you will end up with negative 3.608 volt. Okay. That's all. These are the examples I'm going to solve in this chapter. I'm going to post one more video about the power in this chapter and then move on to the next chapter. Thank you very much.